In last class, we did discuss about events and then rand case. Rand case means what is the difference between the rand case and normal case? Normal case, we are selecting some events. Okay, based on the selection, we are selecting multiple values. Okay, so there is no weightage option in the normal case. Rand case, we have a weightage. Based on the weightage, how many times it is getting repeating. So it depends upon the number of weightage. Okay, if weight is more, then that particular value will be repeating more number of times. Okay, the more probability of chances of getting that value. Okay, and then IPC, inter-process communication. In that, we have discussed about events, okay, and then semaphore and mailbox. Okay, later we will discuss about semaphore and mailbox. Mainly events, synchronization purpose. Okay, most of the events are taken for synchronizing purpose. That means some person is triggering the event and one person is waiting for that event. That event will be happen. Okay, so triggering, and then in that triggering also two types of events are there: blocking and non-blocking. Blocking means same time point of unit. Okay, blocking means we have implication operator. If we trigger before that, you need to wait for the event occurs. Otherwise, the event may be chances of missing is there. Okay, and then non-blocking, we are scheduling. So it will be executing in non-blocking region, NBA region. That means the event occurs at a active region, it will be executed in the NBA region. Okay. So at the same timestamp, we are triggering and then waiting for the event. It will occur for non-blocking event. Okay. At the rate is that waiting for the event, and also we have another waiting for wait of event dot trigger. Okay, so that is also waiting for the event. Okay, four conditions we are checking there. One is implication operator blocking and non-blocking, and then waiting for the event at the rate, and then wait order. Okay, so today we'll discuss about wait ordering system verilog. What is that wait order? So wait order means you have some different events like E1, E2, E3. Three events are there. Okay. How you are representing the events in your declaration, that event declaration, event E1, E2, E3. In that way you have declared. And then wait order also, same order we need to wait for that. Okay. If we are changing the weights, sorry, if we are changing the order, then the event may be getting failing, chances of failing. Okay. So the order we need to maintain the same. See, I am checking that I have an order. One of the most weight order means it helps to answer very important like how the events will be occurred. Okay, so how the events will be occurred in your ordering, so that defines the weight order. That means e1 e2 e3. Okay, so if you are writing that e1 will be first, okay, and e2 will be second, e3 will be third, but you're in weight order, E3 will be first, E1 will be next, and E2 will be last, means then order is missing. Okay, that's what. Did event occurs in correct sequence or not? Okay, that tells you that weight order event. Okay, how we are synchronizing the constructs. So that means how we are synchronizing the events that will occurs here. Okay, whatever the order we are executing, based on that order, we are getting the events. See, I am checking that did event A happens, or event B happens, or event C happens. If checks that A happens before B, or B happens before C. Okay, A, B, C order is there. Okay, you know, solve before constraint. Solve before constraint means we are prioritizing, right? Who is executing first and who is executing next? we are giving the some priority like implication operator. Okay, so first the left hand side part is executed, then go for the right hand side part. Similarly, here also I am having three events, event A, B, C. So, is that checking that did A happens before B or did B happens before C? That we need to check that. Okay. So that defines that weight order, weight of event A, comma B, comma C. The same order we need to check that. Otherwise, the event may be failed. Okay. So same way, in protocol verification, first we need to check that handshake is happening or not. Handshake means communication, establishing the communication between the two protocols. Okay. So that is whenever you are answering my call, so first I am checking that hello. Okay. So that means you are connected or not. Right? Same way here also handshake mechanism we need to check this. So that handshake mechanism establishes the communication between the two systems. Okay. So same way I'm checking that handshaking is happening or not. And reset is sequencing or not. Reset means initializing the condition. Based on that, I know where I'm now. Okay. So that is the reset operation. And then interrupt validation. Is there any interrupts is getting? That means you are doing some operation, okay, or you are working on something, then you got a mail, then mail is the highest priority you are giving. Then whatever the program you are running, that will be going to the ISR, right? Interrupt service routine. Okay, so that is the reason uh, we have to give the highest priority for the interrupt service routines. Okay, and UVM synchronization. Synchronization, I told you, whatever the information we are sending, that will be synchronized with the clock. Okay, then only we can know so which sequence is executing and which are not executing and who is getting giving the output and who is not giving the output. Okay. So that is the wait order. Waits the list of events and verify they occur in the exact specified order or not. That is the wait order. It will tell you. So that means I am giving some priority. Okay, or I am giving some ordering sequence order. 1, 2, 3, 4, 5, 6. Okay, in this way I am giving the order. Okay, first he need to execute. After that her and then her. Okay, so based on that, the wait order will be executed. Same way, here also I am giving that my order is event 1, okay, and then event 2 and event 3. Okay, this is my wait order of event 1, 2, 3. If it is success, then the order is correct. If it is fails, means the order is wrong. Okay. So event is not happening properly. So that's what we are checking there. So same way I'm checking my order is event 1, 2, 3. So if it is the same order, that means the event declaration also same order, event 1, 2 and 3. That means you need to trigger the event 1 and then wait for the event 1. After that, same way, the triggering the event 2 and wait for the event 2. Same way, event 3, triggering the event 3 and wait for the event 3. So this is hash 10 and this is at 0 and this is hash 20 and this is hash 30. Okay, so that means the ordering is changed. Okay, hash 10 means the you are executing the same order, but delays are different. So the delays will also be same. First, we need to execute that event 1. Okay, for that delay should be less, and compared to that event 2. Okay, next, so to increase the delay for the event 2, and then event 3. So it will take some time, right? Then event 3 also we need to give some delay, etc. Okay. So that is the reason I need to give the different. So this is the 30 and this is 70 we can give, and this is 90. Okay. Then the delay also on. Okay, first delay, first event is taking 30 seconds delay. Second event taking 90 seconds delay, or sorry, 70 seconds delay. And third event taking 30 seconds delay. Okay, so that's what I am having three events. Event declaration, this is my event declaration. Event 1, this is the event declaration. How I am declaring that? Events E1, E2 and E3. See, three events are having same delays. That is also possible, right? All are executing at the same delay. Event hash 10. Otherwise, you can take that hash 10 and hash 20 and then 30. That is also possible. I am triggering the event 1 at 10 seconds delay, and then you need to wait before for that. Okay, before triggering, we need to wait for that, right? Because I am inside the room, then you rang the bell means I know. Okay, someone is ringing the bell. Then I need to open the door. Okay, because I am waiting for that someone to trigger the bell. Okay, that is the event happening occurs. Okay, here the event missing chance is very less because you are waiting before that to trigger the event. You are waiting after event happens. Then there is no use of waiting, right? So the person already event is happening and then event done already. You miss the event. Then after completion of the event, you are going to the function means what is the use, right? When marriage is happening, okay, so you need to attend for that. But you attended after completion of the marriage, then no one is there in the function hall. Then why you need to go there? Okay, there is no use, right? So same thing here also. Okay. So same order we need to execute E1, E2 and E3. Here 10, 20, 30 delay I am giving. Event 1 is triggering first, after that event 2, after that event 3. Okay. So the order of the event execution is also same. Then only my events will be executed properly. Okay. So then only I can pass the event, otherwise fail the event. I told you wrong order. See, event declaration you have done in 1, 2, 3. Then triggering the event at event 2. After that event 1. And then triggering the event is event 3. But triggering first, which event you are triggering? Event 2. But order is mentioning that event 1. Okay. Wait order is event 1. That is wrong. The triggering event, who is triggering first, that person should be wait first. Otherwise, the event may be missing. Here also, if we want to mention the order, so the order must be same. See, here event 2 is happening first, after that event 1 and then event 3. Or if you are triggering the event, this is the event 1. Okay, so 10 seconds delay, 10 seconds delay, 10 seconds delay. This is event 1, this is event 2 and event 3. Same way you need to mention the order E3, E2 and E1. The order, wait order is also maintained the same factor. Same thing, here I am having reset done. That is one event. Reset done, configuration done, and start done, and transmission done. Four events are there: reset, configuration, start, and transmission. So what is happening first? Reset. After that configuration, and then start, and then transmission done. So the wait order also same thing we need to mention. Otherwise, the setup sequence of execution of whatever the sequence of execution of order events will be failed. Okay. The order of the events in the sequence, whatever the mentioned sequence, in the same order we need to mention. So for join, that means the events will be executing based on the delays, right? In fork join, all are executing parallelly. But who is executing first? Who are having the less delay, that will be executing first, and then next delay, and then next delay. Okay, so I am using here fork join. So event 1 is happening at first, right? So this is the event 1 is happening. Okay, so event 1 is happening at 5 seconds delay. This is 5 nanoseconds delay, and this is 15 nanoseconds delay, and 25 nanoseconds delay. Okay, so three events are occurred. Then wait order is also same order. Otherwise, if I change the delays here, this is 50, and then this is 35. Okay, and this is 45. Who is executing first? E3 will be executing first because this is the delay 35 seconds mentioned. Then order also you need to mention E3, after that E2, and then E1. Okay, E1 having the delay is 50, and then E2 having the delay is 45. Okay, so based on the delay it will execute that events. So out of order events, that means see 20, 10. So first one is 20, second one is 10, and third one is 30. Okay, so three events you have. So initial begin, for join we are applying that. So join none. So join none means what? None of them is joining. Okay, so that means based on the delay it will be executing. After that this is E2 and this is E3, E1 will be executing next. After that, E3 will be executing. Okay. The order of the events also we need to mention that E2 and E3, E1. So in that way we need to mention that for E2, E1, E3. Okay. So E2, E1, E3 order we need to mention. But here fourth join is none of them is joining. Then we need to check that order is happening or not. Anyways, the order is not happening because the delays we are giving. Okay, based on the delays, it is executing the events and triggering the events. For that, we need to wait for the events. Okay, same way here also. Port join. Okay, so port join, we have different tasks. Okay, E1, E2, E3, and then ABC both are working together, and then we are giving the order. Just execute this program. See this program, we have reset done. Event is reset done, configuration done, and start done, and transmission done. Okay, so four events are there. All are having the same delay. Okay, see, I'm having the configuration done, reset done. First, you are triggering the configuration done. After that, reset done, and then uh, start done and transmission done. Then wait order also we have mentioned the same order: reset done, configuration done, start done, and then transmission done. Okay, so is that same order we are executing? No, right? because I have changed the order here. First, I need to execute the configuration done, but here I'm giving that reset done. So, can we get that event pass or fail? Okay, the startup sequence is pass or fail. Obviously, fail, right? See, the setup startup sequence is fail. We got it because the order is missing here. Okay, so what we are giving here, reset done is the first delay. Okay, so reset done is the first, then that means I am giving the delay is 0, hash 0. So is that executing? Hash 0 after that configuration, after that start done, and then reset done. Still fail. Okay, so I will give you the event this one. Delay I'm not mentioned here. Hmm. So that means 0 second delay, the reset I need to get that. Again fail. So just give the delays difference here. This is 20 and hash 30. Okay, and then so 40 here and then 50. So then the wait order is also I need to mention. So I'm just commenting this one. Reset done is that next, right? This is the okay. So same order I think we are executing. Configuration done, reset done, and start done, transmission done. Here we have got pass. Just I want to change this initial begin, this initial begin, and then wait order also. I'm changing here. Okay, copy this one, pasted here. Okay, so where is this event done? This is the event. Just I'm commenting this one up to this one. Okay, then here initial begin, the wait order I'm giving here 70. Okay, this is 70. That means reset done is the first one, right? So same thing. Reset done is the first one. After that, configuration done. Okay. So just I'm giving that configuration done. So same order. Delays I'm changing, right? This is 70. No, I think reset done is the first one. Start done. Transmission done. After that, configuration done. Okay. So just save and run. Is that executing the same order or not? See here the delay is not matter. Okay. Triggering the event is matter. Okay. So that means I am checking the same event order. So what is the order here? Ah, so same first order, right? So delays I am changing, but the order is order of the triggering is same. Okay. Just I'm commenting this one. Configuration done, reset done, and start done after the transmission done. Okay. So, but The delay, whatever the delay we have, they are not taking care of. Just I want to check that. Is that check? See, whatever the delay we have mentioned, so based on the delay, it is not triggering that. Okay. So that means if you gave the delay is higher for the configuration and then less delay for reset, and then that is not checking. Okay. So first it is triggering that configuration. Okay. After that reset done, then start done, transmission done. Order is matters here. Okay. Delay is not checking. So actually I am thinking about based on the delay. So the order is also executing based on the delay. So based on the delay only it is taking that event, but it is not taking. So if we are giving the delay here 90 and here some 10 and here 60. Okay. So but it is executing the same order. 6 sequence setup is fast. Okay. Because configuration done, reset done, start done, and transmission done. If we want to change this delay transmission done is that first if we want to keep it here. Okay. So I just you can comment this one. Then transmit done we need to keep it first. Okay. So then we check that order. Sequence first. So delay is not a matter here. But the event occurs at different delays. Okay. First is triggering whatever the triggering point is there. So because in this initial begin, all are executing at same simulation time. GDET simulation time only it is executing. Okay. So based on the delays, it is getting the outputs right. So same thing if we want to execute at the ordering, this order is maintained the same. First one, second one, third one, fourth one. If we change the order means then the setup is fails. Clear? So that's what. Imagine a security checkpoint where people must pass through that three gates in a sequence: gate A, gate B, and gate C. If the order is changed, it means the entering the if someone enters gate C before gate B, the process is considered as invalid. Okay. So not a matter. So first we need to pass the event. Okay. So first we need to pass through gate A. If you are passing the gate A 10 seconds delay, 100 seconds delay, 120 seconds delay, no matter here. Okay. You need to pass through the gate A first. Okay. And then entering into the gate B. That is also it is taking too much delay, it's not a problem. Because you want to check all the points. You are roaming around all the path. Then after roaming around, then you need to pass the gate 2. And don't skip the gate 2. And then you are jumping to the gate 3 means it's an invalid operation. Okay. So it watches a list of events and verifies that they occur in the exact order what you specify. Okay. So whatever the order you specify, same order it is checking. Okay. Then merging the events. What is that merging the events? Merging means if you have doorbells like front doorbell, back doorbell, and then upside doorbell. Okay, all are connected to same switch, single switch. Then someone triggers at back door. Then even front doorbell also rings. Even upside doorbell also rings there. Okay, that is the event matching. See, event merging, see how we are executing in polymorphism, upcasting we are doing, right? Upcasting parent equal to child. That means the handles we are assigning. Okay. Same way here also the handles we are assigning that the events we are copying. Okay. Here not copying, assigning them. Okay. Merging the events. Actually, what we are thinking about it packet parent P and child C, P equal to C we are mentioning. That means whatever the parent class properties are there, that will be inherited by child. And then child only it is executed. That there is no parent. But here not like that. It is not copying them. Okay. It is just assigning. Okay, combining how many handles we have, all the handles are grouped together, and then if we ring one bell, then all the bells will be ring. Okay, that's what. So merging an event, what is that? One of the least common feature in the system verilog event merging. So event one, event two. If both are so, but very few knows that you can do that E2 equal to E1. Okay. So that means E2 equal to E1. We are merging the events. That means I am giving that aliasing. Like E1 name is also called as E2, or E2 name is also called as E1. So both will respond for triggering one event. Okay. Event 1 you are triggering, event 2 is also triggering. Event 2 you are triggering, event 1 also responds. Okay. That's what the matching. So after assignment, E1 and E2 becomes that aliases of the same event object. This is called event matching. That means the two doorbells are combined together. Imagine two doorbells. Front doorbell is the E1 and back doorbell E2. So initially, if both are not equal, that means each bell rings independently. That means I am not merging the events. Here, what I am doing here, E2 equal to E1. Suppose you connect both the buttons in the same electrical wire, then all the wires will sometimes we are switching on that one light, okay, then entire lights will be on. Okay, that means only one switch we are giving, single wire is connected to all the lights. Okay, so same way here also I am giving that how many events are there, all the events will be connected together. Okay, so now press front door bell or press back door bell, same bell will ring there. Anyone is waiting for the either bell wakes up. So this is exactly what event merging does. So that means uh, he is having one bell and she is having one ring. Okay, so we are independently operating there. So he is having the front bell, it is not connected to the back door bell, and then she is having back door bell and it is not connected to the front door bell. That means if you ring the front door bell, this person only wake up, and then second person not wake up. But it's individual operation. Whenever you are assigning that E1 equal to E2, that means the two bells will be ringing. Okay, if you press one bell, then other bell also ringing, right? So same way here also, I'm merging the events, event 1, 2, 3. One event triggered means all the three events will be triggered. That is the merging of an event. See, event 1 and 2, in system verilog I have two events, event 1 and event 2. that is the declaration of the two events. Okay, so here event 1 and event 2 both are represented. Then event 2 equal to event 1. I am assigning both the events. That means two events are connected to the same point. Okay, points the same object, same event object. All are pointing to the same person. All are pointing to the same person. Okay, so that means so one person is acting while connecting the different events. Okay, while operating the different persons. Where we are using this type of operations, uh, like broadcasting purpose. Okay, one person is presenting something, all are listening. Okay, or one person is operating that. Okay, all are seeing that projector. Okay, one projector we are giving that one screen. Okay, but listeners are many. Okay, so then here listeners also operating. One person is operating and then other person also responding. One person is giving the response, then same response. See, in a group message, okay. So one person you are texting, then all are seeing, right? Then all are waking up. That is the group message starts. Okay, same thing here also. We are applying. See two events, event 2 equal to event 1. If I am triggering the event 1, here waiting for the event 1. So here you are triggering the event 2, but waiting person is event 1. But still we are receiving that. Here you are triggering the event 1 and waiting person is E2. Okay. So if you want to go for some other place, then one person triggers that event means all the persons will be waking up. Okay, so that is the event matching. Why does this work? Like E2 equal to E1, so this means not copying the events, just assigning the events. Okay, so both are refers to the same name. It means that both names refers to the same event object. Okay, if triggering one triggers both. Okay, waiting on one wakes up from either one. That means one person waking up, then you can also waking up, like our PGs. So in PGs, one person waking up means the other person also wakes up, right? So because one person switch on the light means all the persons are seeing that, right? So that is the merging events. Okay. Event 1, event 2, event A and event B. So after merging, both are connected together. Then one person wake up, so other person is also triggering that. So that's what. Here triggering person E2 and waiting person E1, or triggering person E1 and waiting person is E2. Okay, that's what. Same thing here also. Multiple waiters also there. Okay, because E1 and E2, so E1 is triggering, E1 is waiting, and E2 is also waiting for that. Both the process will be initiated by one person. Okay, so same way, wait triggering. Event 2 is triggering that, and event 1 is waiting. Okay, so I am waiting for that someone to trigger. Shared notification. So shared notification means group chat in your life. So one person we are giving the response means so then in manager in groups manager is texting. So we have 10 members as a team. Then one person is responded means all the persons also agreeing that. Okay. That's what. Okay. So just see this summary. Out of order, have you seen that? Okay, just want to check this one. Out of order sequence. Out of order sequence means so E1, E2, E3 are the three events. Okay, here E1, E2, E3. Same order I am representing. See, here I am using that fork join. Okay, fork join any, fork join none. So I am using that fork join. Then event 1, 2, 3. So all are having the same delays, right? Event 1 is having the same delay, E2 is also having the same delay, and E3 is also having the same delay. Okay, so which one is triggering first? E1, after that E2, and then E3 will be triggering. The order of the wait order is also mentioned same, E1 comma E2 comma E3. Okay, just check that is that executing out of order or not. You are getting pass or fail. Here, see fourth join event is passing at 200. Okay, because all the three events will be joining together. Okay, event 1, 2 and 3. So same order is there. Just check that your order will be differ here, and then E2, E1, E3. Okay, I'm giving that E2, E1, E3. So E2 means first, right? So then this is the delay 200, and this then next order is E1. E1 means this is I am giving that 250, and here I am giving 300. We have seen already the delays is not matter. Okay, ordering the events is matter, I think. Just check that. I'm changing the delays and giving the code join, and ordering the event will be code join, whatever the order you are giving. See, E2 is the first one. Okay, and then previously I'm not giving any code join, right? All are executing at different delays. At the time, the order of the event will be matter. Here, out of order is also executing because you are giving that code join. Okay, just I'm giving that code join none here. So code join any. So code join any means any one of the event will be executing first. So what is the event one here? So this is 250, right? Just I am giving 20, E1. Okay, is that executing out of order or not? E1 is 20, right? So, but your order is event 2. Okay, see failing. So previously, I am giving that different order. See, here E1 is the first one. Okay, fourth join, any I am giving. Okay, so then I need to give this order is E1 is first, right? After that E1, next one is E2 and E3. Okay, so that means third one we can uncomment it. Check that is that passing or not. E1, E2, E3. Okay, first one is the same order. Passing. Okay, fourth join in E. Previously, the delays not a matter. Now here fourth join we are using. Now delays are matter. Okay, the order E1 and then E2. After that E3. So in background, the remaining process is also executing, right? Okay, out of order is executing while using fourth join. Okay, so fourth join none, fourth join any, fourth join. So just execute all the conditions. Then waiting, merging and events, right? This is the merging. Uh, See here, I'm checking that event, two events E1 and E2, and E2 equal to E1. Here I'm triggering that E2 and waiting for the E1. Okay, so is that executing or not? It is executing, right? Because both events are combined together. Then waiting for the event one, so waiting at 0 seconds, so that is the dollar display, and E1 will be happened at 20 seconds delay. Okay, the event will be received at 20 seconds delay. So if you want to change the condition, here E1 is triggering and E2 is waiting. Okay, that is also occurring because E2 equal to E1 is done. Then events assignment is done. Then two events are merged together. Mail merging, right? So we are grouping the different mails and sending again only data. Okay. See, 0 is waiting and then 20 is receiving. Okay. So that is what event matching. Okay. Just take 5 minutes, 2 minutes break. Okay, passing an event in system verilog. Passing means functions we have, we can pass that events. Okay, and then task we have, we can pass the event. Okay, in fourth join we are passing the events. Okay, that is what passing an event. Like in functions, how we can pass the variables, right? Pass by value, pass by reference, we know, right? Pass by reference means it is getting the same value. Okay, whenever you are changing that, okay, it can be changing the other value also. Pass by value means it is not everything. Okay, same way, here also I am using that passing in events. How we can pass an event, and then how do you debug that? So see here two people in a room. Person A ring a bell, person B waits until that bell rings. Okay. So that means the event will be merging. Okay. Or a event will be happening somewhere and then someone is waiting for that. Okay. So she is ringing the bell. I am waiting in the room. Okay. Based on that event will be happening, right? The bell is an event. Okay. Instead of giving person B a new bell, we give him the same bell. Okay, same bell handle. Like merging the events, right? So how we are merging the events or same handles we are equating together. Here also we are passing the bells, but whatever the event is there, that event we are passing to the second event also. That means handle will be the same, like polymorphism. So polymorphism, you are saying what we are saying that uh, same parent, okay, multiple childs you are assigning that. Okay, you are creating multiple objects and assigning to that parent, right? So A equal to C, A equal to D, A equal to E. So in this way I am assigning them. Same way, here also I am passing an event. That event means that exactly. Suppose now when a person A rings the bell and person B hears, that's what. I can pass the bell. Okay, he can hear the bell. Okay, or he is ringing the bell and hearing the bell. Okay, so that's what passing an event. That means I'm passing the handle to the second person. Okay, then the first person is affecting, then second person is also affecting them. Okay, that's exactly passing an event means in that. So why do we need event passing? That means generator creates the transaction, driver waits for that signal, right? In a transaction, who is generating the generator? Generator is generating the different transactions. That means what you are going to the restaurant. Okay, you are the generator. So you are thinking in your mind what I want to eat. Okay, so then who is waiting? The waiter is waiting, right? So same way here also the other person is waiting for that. Okay, driver is waiting for that, and monitor notifies that. Okay, monitor notifies that means the CC camera will always observe that when we are coming, when we are leaving, and what we are doing. All the activities are observed by the monitor. So it is nothing will be doing. Okay, just it is observing only what is the activity, how I am teaching, where, what time I came here. Okay, all these things it is capturing monitor. Okay, same way here multiple components must synchronize each other. Based on that only the event is happening properly. Suppose you are conducting a fest. Okay, so different groups are there. If one group fail means the event will be failed. Okay, one is so someone is saying that event is not good, not organizing well. Then the team committee members will be affected. Same way here also, and passing the events. One person is passing the event, the other person is also affecting them. Instead of using global events everywhere, we pass an event. That means handles we are passing that. Okay, pass event handles. Whatever the handles we are having, that handle we are passing to the other person. Okay, so that's what. See, event one is there. Okay, event one I'm declaring in my module, and then I'm taking some other function. Inside the function, I'm passing the another argument. Okay, and another event I'm taking there. Then I want to utilize the same event in that same function also. That means in your function there is an argument. That argument handle is assigned to the event handle. Then the function argument is also act like an event, right? How we are passing the constructor new in A comma B, and then address and data. A is related to address and B is related to data. How we are passing the arguments, right? Same way. The A and B will be acting like an address and data. If you pass the value for address, A is also affected. If you pass the value for A, address is also affected, right? So same way. So that's what passing an event through a constructor. Okay, basic constructor function new event E. Here event TRE. The two events we don't want to use it. Okay, same event I can utilize in everywhere. Okay, so same constructor I'm having the argument is event E. Then I'm assigning that transaction underscore E and then event E. Both are same events. If you pass the E value or if you pass the PR hyphen E, then both the events will be occurring. Okay, so no copy happens. Both handles point to the same event. Okay, I'm not copying any events. Okay, just I'm assigning that. Whatever the event I'm having, that event will be happening at the same time. Okay, same way. Uh, Module creates that event. So here I am creating the event and transaction TR, then TR equal to new of event. Okay, that means I'm passing the event here. Okay, so this is my class transaction. The handle is transaction here. I'm creating the object here. Okay, so this is creating object. In this object, you are passing the arguments EV. So EV is that handle for the event. Okay, same EV will be assigning to that E, and this E will be assigned to that transaction dot E. Okay, transaction underscore E. See, module here I am passing that module event module TB event EV. Okay, my class transaction event underscore E, and then function argument, that means constructor E equal to underscore E, then task wait for the event. Okay, you are waiting for the event and displaying the something, and wait for the triggering some event, and event is received. Okay, so once event is received, then what will happen here? Then transaction new equal to E. So that means EV will be waiting here. So that EV will be happen to E, and then this also affecting. One person EV is affecting, then E also affecting that, and transaction underscore E is also affecting. Okay, that is passing an event. Same event I'm utilizing everywhere in my module. Okay, so that's what. So here transaction dot wait for the event. What is the wait for the event? So this is the task. Wait for the event. We are having the task that we are waiting for the transaction underscore E is triggered. Okay, that means someone is triggering. Anyone, E is also triggering or EB also triggering. If anyone is triggering, then transaction E is happening. Okay, so he is waiting person. Then here I trigger that EV I can trigger. Okay, this is the triggering event. Who is triggering here? EV. So EV is representing that object handle. Okay, so which one is object handle? This one. So this is the event E. Okay, because see I am taking that function new. In this function new, I am having some address, int address. Okay, so here I am having int A. Okay, then A equal to address you are assigning that. That means address value will be assigned to A. Now in my module TB, what I am representing, this is my transaction. Okay, TR, then TR equal to new method I am assigning that. Here 100 I have assigned. That 100 is assigned to address, then address is assigned to A. Then whatever the A value is there, whatever the new value in constructed you are assigning some value, that will be assigned to in A also. Okay, here also I am triggering the event EV. That means this EV is triggered and this person is affecting here. This person is affecting means transaction E is also affecting. That means one person triggered other person is waiting. Okay, here I'm passing the handles only, not the events. Okay, that's what passing an event. Same, passing an event to the task. Same way, here also I have considered the task, right? Wait for the event. Same, task triggering event. Then here, what is the event I'm considered here? Event E1. Okay, same event I'm taking the another handle. Okay, if the triggering event EV, then the wait event is also triggering because same event I'm considering. Dollar display waiting and event triggered and received the event because the two these two tasks are working parallel. Four joiner can consider here. Then how many tasks are you are taking? All the tasks are executing parallel. Here, wait an event is executing and triggering is also executing at the same time. That means the two events will be occurred at the same time when you are triggering one handle. Okay. So passing in events to the function. Same way I'm passing the events to the function. So then function void triggering the event. So this is my name of the function and the event E. Okay. Once you call this event E, then event done also working. Okay. See, because both are same, right? Event E is triggered, then done also triggering. Okay. So wait for done triggered and dollar display done is received. And initial begin trigger is done. So this trigger done I am calling here. Okay. Based on the port join, I can execute the different events like a wait and dollar display and triggering done. Both are executing at the same time. Understood, right? How we are passing the events. Okay. Same way here also I am passing the events between the classes. Okay, I'm considering the class producer and then class consumer. Okay, so here I'm taking two classes. One is for producer class, that means master and event done, and in function new I'm passing the event. One person is triggering the event, then other person is producer also done here, and consumer class. Same event I'm taking. Okay, same event I am taking here and done here. That means two classes are having the same event. Okay. Then in module we can assign the class handles for the producer and consumer. We can assign the handles. Okay. So in module TP, what I am having class A. This is my class A, and then event local E. This local EV and then EV both are same. Okay, and then I'm triggering the task it here, and then local EV triggering here. This one triggered, this one is also affecting, or this one is triggered and this one is also affecting. And initial begin, I'm assigning the new value, and then A is triggering, wait for the event, and then receiving the event. Okay, that's what passing an event. Same thing. Synchronizing multiple events are there. We can synchronize that. Okay, class generator is there, class driver, class monitor, class scoreboard. How many events are there? All the events we can pass to same handle. Okay. See, one handle I am assigning that all will be working. See, uh, finish event. This finish event is assigned to event. Here done, 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 done. So in generator also same event I am using, and monitor also I am using same event, driver also using the same event. So that event will be passing to the all the classes. Okay. So all components are notified instantly. This pattern is heavily used in our verification because one event we can pass to the multiple components. Just check this summary. Passing an event does not create the new event. Okay. So we are using the same event. Okay. Just we are passing the handle only. Based on the handle, we are getting the output. Here. Passing an event through the constructor. See here, look at here. So module TV and then event TV and then class transaction I am taking the transaction E. So through constructor I am passing the event E that will be assigned to transaction underscore E. Then dollar display the event handle is assigned. Okay, so event handle assigned. After that, task is waiting for the event. Wait for the event at the rate. So I am waiting here. Okay, someone to trigger. Then where you are triggering? Here you are triggering. At what is the delay? Hash 20 and module is triggering the event and then hash 20. So then module is triggering the event. See, both the events will be triggering at the different intervals of time. One event you are triggering, then the wait condition is executing. Then this is executing, receiving the event and handling also executing. Just check that. See, at 0th stimulation time, the event handle is assigned. Okay, this is the 0th simulation time. Event handle is assigned. And then transaction class, event received. When you are receiving that, module is triggering the event. At 20 seconds delay, I am triggering the event. Okay. So if you are triggering the event, then the transaction class is event received. Okay. That event is received. Why here 40 came here? Because another 20 is there. Okay. Again, we are triggering the event. So just module triggering event again. Okay, that event will be triggered again. That is the reason we got that transaction event is received at 40. Okay, so here I am triggering the event again. Once you are triggering, and here the transaction class event is received. Okay, so here I am triggering the event 20th second delay. Then my transaction is received here. Okay, at 20 seconds delay only, I have received my event. Again you are triggering. Suppose you can change the delay here. So here you can apply that 60 seconds delay. Then the event will be triggered at 80 seconds. Because the previous triggering event is 20. Then adding that 20, so 80 will be getting. See, 80. Same handle and triggering the event. That is the passing event. Understood, right?